Good morning, friends. We are going to speak about analog. I hope, and I think you know of analog. If you don't know, don't worry. I'm going to explain what analog basically means. Analog is actually things we feel, like as humans, what we feel. As humans, we feel the heat, feel the temperature of things. We can see how light is. And then when we twist things like our radio stations, our radio, sometimes we have our potential meter, we twist it, we actually see how we twist it. We know the level of frequency we twist it. Now this is analog. But in a digital world, we're talking of our basic digital computers, our bytes and other things. Now, in this lesson, we are going to talk of how we're going to convert this analog into digital so that our computer can be able to analyze it. Now we have our sensors on the Arduino, actually on a TinyLab. We have our port pin, no, we have our A0 pin. We're defining it now. We have our A0 pin. This our A0 pin is actually for our potentiometer. Our potentiometer is actually, it can be twisted. We can turn it to the level we want. It shows the frequency. Now we have our LDR. The LDR is also for our light, our LED dependent resistance. Actually, it's our LED dependent resistance, and it is connected with the analog sensor of A2 on our TinyLab. We have we define our LM35 pin A3. This actually is a LED of our temperature. Yes, it's a LED that senses our, it's a sensor that actually tells us the amount of heat, the temperature we have in our life. Now we have our void setup. The void setup, as long as we have already defined this, now we come to the void setup. Here we are basically going to enter something. Why are we doing this serial point begin? We are doing serial point begin because we are going to be entering, we're going to be twisting something, meaning there is going to be a release of something on our monitor. It has to really tell us the value. It's talking about the value here. So to be able to tell us the value, we are going to use our serial. We have serial monitor. There is a serial monitor actually on our computer when we open our Arduino IDE. Now we have our we're setting our serial board with 9600. There are different boards actually on our Arduino. Now we have our serial point begin 9600, meaning it's going to open the 9600 board. Okay, now until serial monitor is opened, now we have to wait until our serial monitor is open before we do any operation. We say while it is not serial, okay, serial point print. What do we mean while it is not serial? Meaning while these values are not yet, while the values of the temperature and then the light, the LED emitting, the LED dependent resistance and the temperatures are not yet censored, they are not yet captured, we write serial point print and ln. This print ln actually means new line. Okay, it actually means in a new line. An example of an analog entrance. It actually means an example of our entrance, of our what, analog entrance. Okay, it's an example of our analog entrance. Okay, example of an analog entrance. Now we delay it for 500. What does it mean, delaying it for 500? That means delaying it for half a second. Okay, now we come to our void loop. Our void loop here, we are going to read the value of our potential meter, meaning when we twist our potential meter to any level, okay, we are going to read it. Now that's when we said input value. This input value is basically, it means we are going to read the digital value. Okay, normally our potential meter is frequency. Okay, but now if we write input value, that means we want it to be from an analog to the digital. Now that also means we have our input is equal to what, our analog read port pin. Okay, it means our analog read port pin. Now it will twist, and the level we twist it, okay, we have our analog grid. Now we have our port pin. It's equal to analog grid port pin. That will give us our what? The value for the potentiometer. Now let's come, we're going to read our LDR. The LDR is actually lead dependent resistor and is connected with the A2 on our tiny lab. We're going to read it and then convert it. Now we say int LDR value. Why do we say int LDR value here? We say int LDR value in order for us to make it a digital, okay? Because our computer actually senses digital. Now we have 2500. This is actually, we are going to we have to convert it. It has its own formula. We have 2500, okay, 0.0, okay. Why are we using this point? It's actually like a decimal, okay, divided by, we have our analog read LDR pin, okay. The value it reads, actually, that is, it reads the value. Now times, we have 5.0, now 5.0, because our computer reads digital, we have to actually convert it. 5 times, now times, we open our parenthesis, okay, 5.0 divided by 1024.0. Here we can see 0.0. Why do we use 0.0? Because we want it to be in a decimal. Okay, now we continue, we're still continuing. We close it, we close the bracket here, this bracket, we close it. Now we close the main bracket here. Now minus 500, okay. Now we close it, we divide it by 10.0, okay. Now reading our LM35. What do we mean by reading our LM35? Meaning, I'm talking of us reading our temperature, okay. Basically, we're reading our temperature. We read our temperature and convert it to centigrade, okay. Normally, you know, temperatures are into centigrade. Now we have int LM35 value. What do we mean by int LM35 value? Meaning, this is going to be read by our computer. Our computer is going to realize that this is going to take it as a digital, okay, from an analog to a digital. Now we have 5.0 times analog rate, okay, it analog reads it. Now LM35, okay, our pin, okay, times 100.0 divided by 1024, okay. With this, that actually means we have converted our analog into digital. Now we can print it on our board. Now we say serial point print, okay. We say potential meter value, okay. Potential meter value right now here. Now we're going to print our potential meter value as a digital. We have serial point print ln. This serial point print ln actually means, this ln actually means it's going to be in a new line. Now we have port value. The port value is going to be this, our value, okay, the value here. After it has analog read it has analog read our port pin. Now we have analog read. Now we have port value. The port value is going to be a digital, in a digital form. And we have our serial point print, okay, LDR value. We write the LDR value. You can actually write what you want, but writing LDR value will be very good because we are dealing with lead dependent resistant, okay, value. Now we say now we say again, we say serial point print ln. Why do we say serial point print ln? That means it should be in a new line. Now we have LDR value. Now our lead dependent resistant value, as we can see here, LDR value, that means it's going to be, it has converted it to actually digital. Now we have serial point print. Now temperature value, our temperature value. Now we have serial point print ln, okay. LM35 value, LM35 is actually our distant temperature, okay, our temperature sensor. But now the value, that means it is the digital value, okay, that the computer can understand. Now we delay it to 100. Delaying it to 100, what does it mean? It actually means we are delaying it to a 10% of a second, okay, a 10% of a second. Now we close it. With this, when we twist our potentiometer, when we change it, we are changing the frequencies of our potentiometer. It changes, actually, changes the values. It changes the values of our potentiometers, and it actually knows what's the name, the temperature. It takes the temperature of our surrounding, and then it converts it in such a way that the computer can be able to understand it. It also takes the lead dependent resistance, the lead dependent resistance, the sensors there actually takes them, it reads it and convert it into our digital for our computer to be able to display it on our serial mode with our serial board. With this, we can actually see the values it actually has, the value it has converted from our analog to our digital, from our analog to our digital converter, ADC. Thank you very much for listening. If you don't understand, you can actually comment on this video, and I am ready to actually help you at all cost. Thank you very much.